So in this clip, we're going to be moving away from the interactive shell and looking more at Python's context in the larger world. We assume that the internet's part of that context, and here I am at a website, actually my website, one of them, coming into the source code and looking for some interesting source code to download. I'm going to put that on my local hard drive. This is a typical Windows computer. And there's going to be multiple Pythons in this one, and that's, one of them came with Hewlett-Packard. I installed the other two, and here I'm saving my source code to my local drive. Now, here's where I get confused. I'm in Python 2.4. That's how I started, and now I'm drilling down under my 2.4, kind of the basement, looking for side packages, and it's empty. There's some subfolders. It's not what I expected. So I go, oh yeah, duh, I'm using the wrong one. So I go into Python 2.5, which has its own tree. Now, Linux, it's going to be similar. You're going to have the same, tree differentiation. So now I've found my module. I'm happy. There's my source code. And this will be the topic of our next clip. So here we're looking at code that we downloaded off the web a minute ago. And it's called groups py because it has some group theory concepts going. But to zoom in on a particular feature of Python syntax, you'll notice these double underline guys. They're kind of like ribs in a creature being the class, and the class is like the template or blueprint. And what we're going to do is import code from a module so that we keep things compartmentalized. We don't have to have everything going at once. We just want P, that's the creature template, the class, and then we're going to create two objects of type P. We're going to create the 10 object and the 11 object. Well, my num is kind of lame naming here. Naming is sometimes not my forte. So what's 10 times 11? We all know is it's 110. But because these are P numbers, or I don't know, call them P numbers, if you multiply them together, even though they look like they're just 10 and 11, they actually give a different product. Now why? Well, because you have the power as the coder, as the programmer, to override what's meant by multiplication. So here I am task switching, and I end up back where I was. So where you look in this code, you'll see this multiplication method. That's what the little asterisk or the multiplication operator invokes. So we have control, and that's so cool about Python.